In this lesson, we will learn about polar and non-polar bonds. We will use some resources from my Teachers Pay Teachers, which you can find a link to in the video description below. So what is a polar bond? Polar bonds occur only in covalent substances which contain covalent bonds. A bond is considered polar when there is an unequal sharing of electrons due to a difference in electronegativities between the two atoms involved. Remember, electronegativity is an atom's ability to attract electrons, and it increases from the left to the right of the periodic table and from the bottom to the top of the periodic table. So, if we take two nonmetals found in different positions on the table, they will have different electronegativities. For example, hydrogen and oxygen. Hence, any covalent bond which forms between these will be a polar bond. So this is a polar bond. And this very bond can be found in a water molecule. So what does it mean to have a polar bond? If we take the example of the bond between hydrogen and oxygen in water, the oxygen is more electronegative than the hydrogen, and the electrons, which are shared in the covalent bond, will spend a greater amount of time near the oxygen than they will near the hydrogen. As a result, the oxygen obtains a partially negative charge, as it is rich in negative electrons, while the hydrogen gains a partial positive charge, as it lacks electrons relative to the number of protons in the nucleus. This produces a positive pole and a negative pole in the bond, and hence the term polar bond. What is a nonpolar bond? A bond is considered nonpolar when there is an equal sharing of electrons due to there being no difference in electronegativity between the atoms involved. Truly nonpolar bonds only occur when two atoms which are bonded are the same element. For example, when two hydrogen atoms bond in the formation of H2 or hydrogen gas. Here, the shared electrons spend an equal amount of time around each hydrogen atom, and hence neither atom acquires a partially positive or partially negative charge. There are no poles to the bond, and therefore it is a non-polar bond. So now we're going to turn to some questions similar to those found in tests and exams for a senior secondary chemistry course. These questions come from the Molecular Shape, Polarity and Intermolecular Forces resource, which is found on my Teachers Pay Teachers. So, if you find them valuable, you will want to check these out. The first question says, explain why the CO bond in carbon monoxide is a polar bond, while the OO bond in oxygen is nonpolar. Have a moment to think about this, perhaps pause the video and write your answer. Consider that it's worth 6 marks, and consider that it would be a good idea to draw a diagram to represent each of these molecules and the bonds involved. So this is the first section where I have drawn up a diagram representing the bonds in the carbon monoxide between carbon and oxygen, and the bonds between the two oxygen atoms in an oxygen molecule. And I have correctly labelled that the oxygen is negatively charged in the carbon monoxide and the carbon is positively charged in the carbon monoxide, whereas there is no assignment of charges in the oxygen because both elements have the same electronegativity, and therefore it is a nonpolar bond. Now I'm showing you a marking guide which thoroughly explains the question. So, first of all, oxygen is more electronegative than carbon. As a result, the electrons in the carbon-oxygen bond spend more time around the oxygen than they do around the carbon atom. This makes the oxygen slightly negative and the carbon slightly positive, or this produces a polar bond. In oxygen, Both of the oxygen atoms have the same electronegativity, so they share the bond electrons equally, resulting in neither oxygen being positive or negative, or a non-polar bond being formed. Draw the following molecules with their correct molecular shape and identify the polar and non-polar bonds. We have C2H4, or ethene, bromine gas, and sulfur trioxide. The first molecule, ethene, has 2 carbon atoms which have 3 bonds to each of the carbon atoms, and as a result they have a trigonal planar geometry around the carbon atoms. I have identified that the bond between the 2 carbon atoms in ethene is a non-polar bond. The reason for this is because the 2 atoms being of the same element have the same electronegativities and share the shared electrons equally, and as a result are not charged. However, the bond between the carbon and the hydrogen is a polar bond. The carbon has a slightly higher electronegativity than the hydrogen, and as a result it acquires a slightly negative charge, and the hydrogen acquires a slightly positive charge. So this is an example of a polar bond. Our second molecule is bromine gas. Bromine, containing 2 bromine atoms of equal electronegativity, is a non-polar bond. Sulfur trioxide contains polar bonds. We have a sulfur atom in the center and 3 bonded oxygens to the sulfur atom, which produces a trigonal planar geometry. Each of the sulfur-oxygen bonds is a polar bond because the oxygen contains a greater electronegativity than the sulfur, the oxygens acquire a slightly negative charge, and the sulfur acquires a slightly positive charge, and as a result of this we have polar bonds in this molecule. Now, an interesting note about the Lewis diagram shown here for the sulfur trioxide is that despite it being correct in terms of the number of electrons involved, it's an inaccurate representation because there is resonance between the sulfur and oxygens in this bond. So each of those bonds is actually more of a 1.3 bond as opposed to having 2 single bonds and a double bond. So, why do polar bonds matter? The presence of polar bonds can lead to charge differences across a molecule, creating a polar molecule. An example of this is ammonia, NH3. The presence of polar bonds affects a molecule's properties, such as the solubility in water or boiling points. In the case of ammonia, it has a boiling point of -33 degrees Celsius and is highly water soluble, and this is because it is a strongly polar molecule. To learn more about this and other subjects, and to obtain premium resources to enhance your classes and revision, access my YouTube page and check out my resources on Teachers Pay Teachers. I hope this has been helpful, and thank you for watching.